Bazel is good, but the official documentation is so difficult to follow, so I make videos to make learning process easier and happier. Let's look at the Bazel project. There are several important types you need to know. First, the module.bazel file marks the boundary of your Bazel repo. It locates at the repository root. You can declare your Bazel repo name, version, and external dependencies being used by this repo. Second, many build.bazel files exist in your project at different location and path. In Bazel's terminology, a Bazel package is defined as a directory containing a build file. Intuitively, you can think a build file as a collection of Bazel targets within the directory marked by a build file. In a particular example, the directory path cpp is a Bazel package because it has a build.bazel file inside it. I define my cpp targets within this build file, and then I can build it by Bazel build command. The build files are the backbone of your code organization in the repository. You will deeply understand this fact once you have more knowledge and get your hands dirty. The third file is Bazel file. These files are used to define the customized building rules, macros, and other reusable pieces of the building logic. For example, I create the rule printing shell in the greeting.bazel file, then I include this rule in another build file. You may also notice the syntax in the Bazel file is very similar to Python. Yes, this is Star-like language, a subset of the Python. Now it is time to try the Bazel commands by yourselves. Keep in mind what you have seen in the file tree before we run the first build command. Let's build the lib4. The Bazel build command pattern is quite easy. You type Bazel plus build plus the target you would like to build. Bazel says build completed successfully. Now you can see the Bazel cache folders: bazel-bin, bazel-lecture0, bazel-out, bazel-test logs. Since what we built is a CPP library, you can see the .a files has been generated in the Bazel cache folders. What about build the CPP binary main instead? We can build by the same command Bazel build, then we replace the target name to the main binary. And then we can see the main executable exists in the Bazel cache folders. Next, we can try Bazel run command. This command builds the Bazel target first, just like Bazel build, and then immediately it runs the build program. Bazel info says running command line bazel-bin cpp main and prints out I'm full. Now you might ask, what if I type Bazel run cpp main directly without the previous build steps? Let's use Bazel clean command to clear all the previous build caches, and then we have a fresh build. And then we type Bazel run cpp main again, and we can see the Bazel cache folders including the lib4.a and main executable has been existing in the folder after we type Bazel run command, and we can also see that the printout I'm full also existed. Now I want to ask a question. Do you see any patterns on the number of packages being loaded and the number of targets configured, also the number of total actions? I made a table that compares the numbers between build-run and run directly. We can find that the number of packages being loaded, the targets being configured are the same regardless you are using the intermediate steps or not. The number of effective actions are also equal. You can have the impression that Bazel breaks down the building or run command to many smaller steps. The files in the cache folders will be reused to accelerate the building process. The last command I would like to show you is Bazel test. It works similar as Bazel run command, but the target you pass here must be the Bazel testing target. For example, cc-test or py_test. In the end, this is a recap of the video today. Hope you have a good start and make sure you subscribe for the following videos. See you next time.